Welcome to the numerical analysis course. In this lecture, we are going to study Jacobi's method. This is also a method to solve system of linear equations. Before this, we have studied Kraut's method and Koleski's method in last lecture. And this method is iterative. This means you have to perform something again and again and until we reach the solution. And there are only two steps, and it's a very simple method and a very old method proposed in 18th century, right? So given this system of linear equation, for example, this having three variables, but it can be more than three, can be 4, 5 or 6, right? So the method is that in step number 1 we take this equation, the first equation number 1, and we compute x1 using this equation. So we keep x1 on the left hand side and everything else on the right hand side. This means we will get this first iterative equation, right? And from equation number 2 we'll keep x2 on the left and everything else on the right, and from this equation number 3 we keep x3 on the left and everything else on the right. So now we have 3 more equations. We can number those a, b, c, 1, 2, 3, maybe we can call them 4, 5 and 6. Now we have these equations 4, 5, 6. These are not new equations, actually these are obtained using after some rearrangement of these 3 equations 1, 2, 3. So we'll iterate 4, 5 and 6, 4, 5 and 6 until convergence, and for the starting point we'll assume the values of x1, x2 and x3 to be 0. So x1 of 0 is a 0, x2 of 0 is a 0, x3 of 0 is also a 0, and we'll iterate them using these 3 equations 4, 5 and 6. For example, x1 at iteration number 1 would be x2 at iteration number 0, x3 at iteration number 0. x2 at iteration number 1 would be 0, 0, and iteration number 1 would be 0 and 0, right? Similarly, x1 at iteration number 2 would be this obtained in iteration number 1. This is x2 in iteration number 2, and this is x3 in iteration number 2, uses data that was computed in iteration number 1 previous iteration. And in general, x1 at nth iteration would be x2 at one previous computed at one previous iteration. Right, and x3 at n would be x1 at n minus 1 and x2 at n minus 1. So this is how we proceed, and we keep on doing this unless we get to a point where these values don't change. This means we converge, right? So this is a very simple method. Let's understand with the help of an example. We have these 3 equations, linear equations. I have numbered them as 1, 2 and 3, and using 1 we perform step number 1. We perform step number 1. This means that using 1 we will compute the value of x1 or x1 on the left hand side and everything else on the right hand side, and using 2 we get x2 on the left, and using 3 we get x3 on the left and everything else on the right. So now we have these 3 equations 4, 5 and 6, and we can iterate. We can assume a starting point where x1, x2 and x3 are 0, and now we can iterate through them to find new values of x1 and x2 and x3, x1, x2 and x3 unless we converge. So starting point is that x1 of 0 is x2 of 0 is x3 of 0, and we assume them to be equal to 0, right? So at iteration number 1 x1 at iteration number 1 would be 12 plus x2 at iteration number 0. x2 at iteration number 0 minus 2 times x3 at iteration number 0 over 5. And x2 at iteration number 1 is minus 25 minus 3 times x1 at iteration 0 plus 2 times x3 at iteration 0 divided by 8. And x3 at iteration number 1 is 6 minus x1 at iteration number 0 minus x2 at iteration number 0 divided by 4. Since all these values are 0, therefore we'll replace this with a 0. 2 times 0 is a 0. 3 times 0 is a 0. It's a 0. And it's a 0. So this comes out to be 12.5. 5 2s are 10. 5 4s are 20. This is minus 25 by 8 minus 3.125. 6 divided by 4. 4 1s are 4. 24 5s are 20. Right. So we get these three values for x1 and x2 and x3. x1, x2 and x3 after iteration number 1. Now we can perform one other iteration where we find the values of x1, x2, x3. x1, x2 and x3 after iteration number 2. Right. Iteration number 2, we get x1 at iteration number 2 is 12 plus x2 at iteration number 1 minus 2x3 divided by 5. x2 at iteration number 2 would be minus 25 minus 3 times x1 at iteration number 1, 2x3 at iteration number 1 divided by 8, and x3 at iteration number 2 would be 6 minus x1 at iteration number 1 minus x2 at iteration number 2 divided by 4. This is 8. So now we have these values. x2 at iteration number 1 is minus 3.125. This is minus 3.125 minus 2 times x3 at iteration number 1 is 1.5. x1 at iteration number 1 is 2.4. 2.4. x3 at iteration number 1 is 1.5. And x1 at iteration number 1 is 2.4. x2 is minus 3.125. So doing this, we get to some other values which we can calculate. Actually, I have written a Python program for this, and I'll share that on your WhatsApp group pretty soon, so that you may try different equations and you can reach to the result very quickly. So I have also written a Python program for this. That I will share on your WhatsApp group. Right, so the output of my Python program is this. The output of the Python program is this. Iteration number, I get x1, x2 and x3. Right, at iteration number 1, this is 2.4 minus 3.125 and 1.5. The same we computed. The same we have just computed. At iteration number 2, These are the results: x1 at iteration number 2, x2 and x3. These values are 0.99, minus 3.14, 2.12. At iteration number 3, that will use the data that we have computed in iteration number 2, 0.99 minus 2.96, 2.03. In iteration number 4, I get 0.99 minus 2.96, 2.01. At iteration number 5, I get it 1 minus 2.99, 1.99. Seems to be converging at 1, x2 converging, x1 converging to 1, x2 converging to minus 3, and x3 converging to 2. And if I keep on going at 10th iteration, I get 1 minus 3 and 2. So after a number of iterations, in fact after 6 iterations, it seems to be settling down to these values. After 5 iterations, or 5 or 6 iterations, it seems to be converging. Right. So now the last step is the optional step that we always do, but it's optional. It's verification. It's verification of your results. You have computed x1 to be 1, x2, your x2 is minus 3, and your x3 is 2. So let's put these values in equations 1, 2 and 3 and check whether they satisfy these 3 equations. 5 times x1, this is 1, minus x2, minus into minus 3, plus 2 times x3 is 2. This is 5 plus 3 plus 4. Right, it turns out to be 12, that is equal to the right hand side. And equation number 2, 3 times x1 is a 1, plus 8 times x2, this is minus 3, minus 2 times x3, this is 3, minus 8 3s are 24, minus 4. So this is 3 minus 4 is minus 1, minus 24 is minus 25, that is equal to the right hand side of equation number 2. And the last equation, let's see whether these values satisfy the last equation. 1 minus 3 plus 4 times 2. 1 minus 3 is minus 2, plus 4 2s are 8, 8 minus 2 is 6. So it satisfies even the third equation. So our answer is correct. It satisfies all 3 linear equations. That's all for today's lecture. We'll keep on studying more about numerical techniques in our upcoming lectures. Thank you.